Today's lesson is on acid and base nomenclature, or simply how we name acids and bases. One thing you're going to want to get out for this is your ion sheet, so the list of ions with the names on them. If you don't have them memorized, of course, otherwise you're definitely going to want that sheet. Okay, so we'll start by how we name acids. There are two types of acids. We have binary acids and oxyacids. And so we'll start with binary acids because they're the simplest of the two. This is something that contains hydrogen and one other element, or a simple polyatomic ion, one without oxygen in it. So that's a simple definition of it. The rules here, the first word has the prefix hydro to name the hydrogen part of the compound. The rest of the first word consists of the form of the root of the second element plus the suffix "ic." The second word is always acid. Okay, so what we're looking for here is something that's just essentially HX, where X could be a variety of different things. But it starts with H, and there's basically just one other thing here. Okay, so taking that, the prefix of this first one down here, now you may have already heard this name before, but we'll show you why it's called what it's called. The prefix is hydro. Okay, we take the root of the second word, so chlorine becomes chlor, and we add on the suffix "ic", and then the second word is acid, so that is hydrochloric acid. Okay, so you may have heard that term before, but not necessarily known why it was named like that. So this one here, HBr, follows our simple binary acid setup. So we're going to start this with hydro. Prefix is always hydro. Prefix, or the root of bromine, brome, suffix "ic", acid. Hydrobromic acid is how we name that. So that's how we name binary acids. Pretty simple. So there are other times that we will use the binary naming rules, even though it's not necessarily just HX. And so this is H, and then we have some other kind of ion here that does not have oxygen. Okay, so that whatever that ion is, it's a polyatomic ion that does not have oxygen. So an example here being HCN. Okay, this is a polyatomic ion, the CN, that's right, cyanide if you're looking at your ion sheet, but does not contain oxygen, so we are going to apply the binary naming rule. So we're going to start this with hydro, and then we take the root of the polyatomic ion's name. So we're going to call this hydrocyan, and then we're changing the suffix to "ic", hydrocyanic acid, HCN. Okay, so that's it for binary naming rules, and these are the exceptions if it's not just H with just one other thing, but H plus some other kind of ion that we still use the binary naming rules for. So when do we not use the binary rules? Well, we use it for oxyacids. So this is essentially what we're going to have here is H followed by some sort of polyatomic ion that has oxygen. Okay, so before it was without it when we were talking about binaries. Now we're containing oxygen. So it's an acid that contains both hydrogen and an oxyanion and is referred to as an oxyacid. So oxyanions are anything that's negatively charged, anions are the negatively charged ions, and oxy because it contains oxygen. So things like perchlorate, chlorate, nitrate, nitrite, okay, those are all going to help us form oxyacids. The rules here: identify the oxyanion present. The first word consists of the root of the oxyanion, okay, and the prefixes per or hypo if those are in the name of the ion. The suffix depends on the oxyanion's suffix. If it ends in "ate", the new ending is "ic". If it ends in "ite", the new ending becomes "us", and the second word is always acid. So what we would look at here for these two examples, all right, we need to identify what the oxyanion is present. So what I would do is just mentally separate hydrogen from the rest of this and look at what I have here. Now, NO3 is a nitrate ion, okay, if you look on your ion sheet. So the first word consists of the root of the oxyanion, so NITR, okay. doesn't have any prefix per or hypo in it from our ion sheet. If this was like per nitrate, that's not a thing, but if that were there, it would be per NITR as our root. The suffix depends on the oxyanion suffix. If it was 8, the new ending is ic. So nitrate, this is going to become nitric acid. Okay, so we go from there being a nitrate ion to it being called nitric acid, HNO3. HNO2, same thing. We know this is an oxyanion. It's got oxygen in it. Separate out the hydrogen. NO2 is called nitrite, an I. Same thing, so we've now identified the oxyanion. We take the root, which was the NITR, and the new suffix, since it used to end in ite, is now us, so this is nitrous acid. Okay, and that's how we do that. All right. An example of where we would use these per or hypo. So for instance, looking right here, this HClO4. Okay. The ClO4 is a perchlorate ion. So the name of HClO4 is going to be perchloric acid. Okay, so that's how we would do that, changing the 8 to ic, and we kept the per there because that was in the name of the oxyanion. Okay, so for naming bases, there are two types of bases that we'll talk about in here. Basically hydroxides, which are super simple to name, and then other compounds which just follow general naming rules. Bases are going to follow everything we've learned so far. So rules are simple. If a compound is soluble and contains a hydroxide ion, then the name of the compound follows the formula name the metal plus the word hydroxide. So really simple here. NaOH, name of the metal is sodium, followed by the word hydroxide, right? Super easy. Sodium hydroxide. CaOH2, it's got the hydroxide ion on it. We just need to name the metal then. Calcium hydroxide, right? Naming hydroxide should be the easiest part of this section. So that's it there. So if it's not a hydroxide and it doesn't start with hydrogen that's telling you it's an acid, it's probably another type of base. Okay, so or if it doesn't start with H something or it doesn't have something and end in OH, it's probably following under this category of other types of bases. So for instance here, NH3, we just use our normal naming rules for that, or if you just know the name of it, NH3 is ammonia. You could also call this nitrogen trihydride if you wanted to go by the technical name there. Or this one here, calcium, using our ionic ruling naming, calcium carbonate. Okay, so we would just split that there, use our ion sheet to name it, right? This one's not an ionic compound. The second one is, so we would just use the ion sheet here, but not here. Okay, so those are the naming rules for bases. Pretty straightforward. Acids have kind of a different way than we've done in the past, but bases just follow what we've always done. Okay, so a convenient flow chart to kind of tell us how we should name something. So, is it an acid or a base? So the question starts with, does the formula start with hydrogen? And this is a good principle to start with usually. I'll explain one exception here in a moment, but does the formula start with hydrogen? If yes, then we're dealing with an acid. If not, it's probably a base, with one exception. So it's an acid. And then the next question you ask yourself, does the formula contain oxygen? If it does not, use your binary rules. Okay, so this is the hydro, whatever the root of the ion is, plus the word acid. So ic. Hydro something, ic, acid, right, would be that side. Oxyacid naming rules. Okay, so if the formula does contain oxygen, then we follow the rules about how to name oxyacids, where you look up the name of the ion and then you change the ending depending on if it was ate or ite. Okay. If it's a base, so if it does not have hydrogen to start the formula, just use your normal, regular naming rules, ionic naming rules and covalent naming rules that we learned first semester. Some additional considerations with names and formulas, some things to keep in mind trying to identify whether something's an acid or a base. Compounds that contain anything that has, like in the middle of it or at the end of the formula, has NH3, NH2, or NH are often bases. So this example here, CH3, CH2, NH2, this is a base, okay? CH3, NH, CH3, same thing. It's got that, one of these three groups, this amine group is what it's called. It's got something like that, okay, on it. But that's going to indicate usually that you're seeing a base. So if you're getting one, for homework, and you're like, I don't know how to identify whether it's an acid or a base because it doesn't have hydroxide, it doesn't start with hydrogen. Okay, if you find this sort of NH group somewhere in the middle of it, it's probably a base. Another thing to recognize that you will see occasionally, and this is that part that I told you just a few minutes ago might break the rule about starting with hydrogens, compounds that end with COOH are acids. Okay, they're organic acids, regardless of how the formula starts. So, for example here, CH3COOH, yes, that does not start with hydrogen, but this is that COOH group there at the end tells you that this is an acid, okay? So this is actually the hydrogen that would come off, okay, when this goes to form an acid, to form hydronium. All right, this would be called acetic acid, by the way. Anyway, so these are a couple of sort of exceptions to what we've seen so far, things that don't necessarily start with hydrogen that tell you it's an acid, or something that doesn't have hydroxide in the formula that very clearly identifies it as a base. Here's a couple of other considerations. I won't ever ask you to name these compounds. It's a little bit above what we can do right now. The one down here, though, we should be able to name this, and we'll learn how to name this later on.